Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at Intro to Chemical Reactions. So right up top we have a formula review. Use the naming review that we used in class to help you with these problems. So down here we have first information on chemical reactions. So right here you have your first example of a chemical reaction. We can always use a sentence to describe what's happening above. So to help us identify the different parts, I've underlined the formulas, and then I've highlighted the symbols that are in between and what they mean. So down below, so this is why formula review, name review is important. So we use the name copper 2 nitrate from right here, reacts with, that's what the plus means, zinc metal, which is Zn, the arrow stands for yields, it react and yields zinc nitrate, again, we just named the compound in the chemical reaction, and correlates with the plus sign, and then copper metal. So we can do something similar for question 3. So what we can do here is we can use the highlighted words to symbolize the symbols that are in between, and then all we have to do is name the different compounds that are here. So the first one, so we have calcium and we have chloride. So calcium, chloride. Then we can see what it says, reacts with, plus sign, reacts with. Then we would have to name the next compound, so AgNO3, silver nitrate. Then we come to an arrow. We can look back up here with arrow and yields. Then we would just have to name the next compound, calcium nitrate. And because then we see this plus sign correlates with and right here. And then we would have to name the next compound, silver chloride. So then we can, oh sorry, I was off the screen a little bit. So then we can just read and double check what it says. Calcium chloride reacts with silver nitrate and yields calcium nitrate and silver chloride. We see the same similarities. So we see that the plus sign is reacts with. We see that the yield sign, or sorry, that the arrow is and yields, and then the second plus is and. So we can use this formula to write out our chemical reactions or chemical equations anytime we want. So just like we can go from the formula, from the chemical equation to a sentence, we can go from a sentence to the formulas in the chemical equation. That's what question 4 is. So when we solve question 4, we just need to go the opposite way. So we need to make the formulas. So I will keep this one page handy right here, so then we can keep looking back up at here to help us with the language. So remember guys, it tells us the name. Don't forget we need to crisscross the charges. The Roman numeral tells us the charge of the metal before we crisscross. So we have nickel. Nickel has a positive 2 charge. Then nitrate. We look up nitrate on our polyatomic ion list. Nitrate has an NO3 with a negative 1 charge. Then we crisscross. So we bring the 2 to the right, the 1 to the left, and then we add parentheses. So we know that it is NiNO3 with a 2. We then see the word reacts with. Reacts with symbolizes a plus sign. Then we reacts with sodium carbonate. So we do the same thing, we crisscross. Sodium has a positive 1 charge. Carbonate, CO3, with a negative 2 charge. Remember, look it up on your polyatomic ion list. So then we crisscross. We bring the 2 to the left side, the 1 to the right side. So it'll become Na2CO3. We then see that the arrow symbolizes yields, and then we have N yields. So then we add an arrow. Next, it tells us nickel 2 carbonate. So then we do the crisscross again. Nickel still has a positive 2 charge. Carbonate still has a negative 2. we notice that the charges are the same, so then we don't have to write them. As we crisscross, they're going to reduce. So that becomes NiCO3. Then we notice that the positive sign relates with and. We have an and, so we have a positive sign. And then lastly, we have sodium nitrate. So we would need to crisscross this. Sodium still has a positive 1 charge. Nitrate still has a negative 1 charge. Then we crisscross. 1, 1. So then it would become NaNO3. And then that is the going from the sentence to the formulas. So you guys can answer 5 and 6. Model it how I just answered 3 and 4. You have to, in 5, you have to go from the formula to the sentence. In 6, you need to go from the sentence to the formulas. Next we have some information on reactions. So as you can tell, this first sentence is this first paragraph is really important. Pretty much all of it is highlighted. So we can just read it out loud together. So we know that during a chemical reaction, new substances are formed. Reactants are transformed into different products. It's important to emphasize the word transformed as well, because what that means is atoms are never created or destroyed. They're only rearranged into new rearrangement into something new. So then a chemical equation represents what happens during the reaction. So right below you have a chemical equation. So it's worth mentioning this sentence, reactants are transformed into products. So we can use the arrow to help us remember this. So if the reactants are turning into products, that means the reactants are on the left side and the products are on the right, because we can follow the arrow, follow the direction of the equation. So the reaction above describes calcium reacting with nitric acid to produce calcium nitrate and hydrogen gas. So you may notice that there's more atoms on the right side than the left side. If that seems strange to you, it's okay for now. Right now we're only going to focus on completing the reactions, and we'll worry about balancing it after. Oh, a cat just came to say hi. So next, and one other thing worth mentioning that you might think is weird is it's written H2 and not H. It's worth mentioning that there are some elements that exist as diatomic molecules. Being a diatomic molecule means that the substance must always be bonded to something. That just makes it much more stable when it's bonded to something else. So the 7 elements that you need to know that are diatomic are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. When these elements are by themselves, when they aren't bonded to anything, they exist as Br2, I2, N2, Cl2, H2, O2, and F2. I remember these by remembering the silly name Mr. Brinkelhoff. I know it's silly, give it a try. It might help you remember it. So this information, everything I just said, will be helpful when we're answering questions 7 and 8. So in question 7, considering the bromine atoms in this reaction. So the bromine atoms are right here on the right side. So why is bromine written as Br2 and not just Br? So it's what we just talked about. Bromine is one of our diatomic molecules. When it's alone, it wants to be bonded to something. That's just how reactive it is. So it ends up finding another bromine atom and they bond together. That way they both fulfill each other's octet and they become stable. So bromine is written as Br2 because it's diatomic. So next, when we're thinking about question B, so the correct formula for lithium bromine is LiBr. Why does it need a 2? Why is it only 1 Br and we don't include that 2 because it's diatomic? So hopefully what you're thinking about is this is an ionic bond. So it happens because the charges exist between each other. So when we make LiBr, lithium bromide, we need to worry about the charges and not worry about how many bromines we have. So lithium has a positive 1 charge, bromine has a negative 1 charge. Then when we crisscross, we put the ones on the bottom, and then it becomes LiBr. We do not need more bromines to balance out the lithium. There's only a 1-to-1 ratio. Next, a little bit more naming practice. Remember, guys, name the reactants. Remember, reactants are on the left side, products are on the right side. So next, so this is the first type of reaction we're going to learn about. It's called single replacement reactions. So the great thing about single replacement reactions is they all follow a similar pattern. So in the pattern that everything follows is as shown right here. So we have a singular element A, which we can think of as silver. It's reacting with a compound like Bc, which would be KCl. Then what happens is A and B, they end up trading places. So then we see that B is now alone and A is bound to C. That's exactly what you saw happen here. We can think of silver as A, and then put K and Cl as B and C. So then what we notice is K is B, B is now alone. Then we see that A and C are together. This is the pattern that all single replacement reactions follow. Sometimes they might be a little bit out of order, but it's okay. So we can just label these similarly to how we labeled them up here. So we'll label calcium A, fluorine B, then magnesium C. So then what we should see happen is we should see two of these trade places. So we'll see that C is now bound to B and A is alone. So what happened here was calcium and magnesium traded places. Calcium is now alone and magnesium is now bound to fluorine, and it was the opposite on the reactant side. So that is a single replacement reaction. This right here, this is the pattern that we'll use to describe all single replacement reactions. This will help you answer question 12. So next, question 9. So question 9 and 10 are very similar. I'll help you with question 9, then you can model question 10 based on what I do in number 9. So answer the following questions below. So we have our chemical equation. It's sodium reacting with magnesium chloride to form sodium chloride and magnesium. So we need to think here. Why can't we produce NaNG, and why does it produce sodium chloride? Why don't the chlorine and the sodium switch places? Why is it magnesium and sodium that do? So to answer this question, we think about the charges. So we can consider the charges of sodium and magnesium. We know sodium is +1, magnesium is +2. So they have similar charges. We need to also consider the charge of chlorine. Chlorine has a charge of -1. So if we label all of the charges on the reactant side, what we notice is the elements that have the same charge trade places. So the sodium and the magnesium. So that's why it doesn't produce. It's also because they're two metals and they have the same charge, so they're going to repel each other. NaNG can't be produced because they have the same charge. So then next, why doesn't it make NaCl2? We notice there's a Cl2 on the left side, but then it only became Cl on the right. So remember, whenever we form new elements, we need to crisscross. Not elements, new compounds. We're making a new compound over here. Whenever we form new compounds, we crisscross. So we found this by crisscrossing the charges. So Na with a +1 charge, chlorine with a -1, and then we crisscrossed, which formed NaCl. And part C, given our answers to parts A and B, do you think that NaCl and Mg are the only products that can be produced? So the only other way to trade places would be to trade the chlorine and the sodium, and we already determined that NaNG can't be produced because they have the same charges, so then yes, these are the only answers. So these are the only products. So now you can model 10 how I just modeled question 9. So over question 11. So question 11 is just like question 4 and 6, just a little bit more practice. So model question 11 off their 4 and 6. Question 12, we've already answered this question in the notes section. So remember back over here when I said question 12, the pattern might be helpful. So look back there to help you. Next, question 13. So when you're completing these following reactions, there are a few things, 2 rules that I use when I complete single replacement reactions. So 1, I'm going to use the charge to determine which elements will trade places. Remember, it's always the same charge that trades places. And then 2, when the atoms trade places, we need to make sure to crisscross the charges on the product side. So I'm going to do A, then you can model B and C how I do A. So we look up the charges on our periodic table. Sodium has a positive 1 charge, calcium has a minus 1 charge, and silver has a positive 1 charge. So remember, we're going to crisscross the stuff that has the same charges. Sorry, we're going to trade places the elements that have the same charges. So that means we're going to trade places with sodium and silver. So that means on this side, the product side, that means sodium is going to be alone. And then we're going to have to crisscross the charges to make what forms when silver combines with chlorine. So we can do that over here. So we have silver with a positive 1 charge. We have chlorine with a negative 1 charge. We crisscross, and then it forms AgCl. So then it's going to be Na plus AgCl. So guys, now try your best to answer 13B and C the same way that I answered 13A. I'll always try to end with a joke. So how many tickles does it take to make a squid laugh? 10 tickles. Well, I hope everyone has a great day. If you have any questions, please make sure you write them down. Bring them to class with you. Bye.